In this video, I went through a playlist with over 64 examples to find the best 12 examples for how to simplify a rational expression. So when we're dealing with simplifying rational expressions, we're going to have a polynomial in the numerator as well as a polynomial in the denominator. And we're going to factor those polynomials and then divide out our common terms or expressions. It can be a lot, and a lot of students struggle with the factoring. That's why I hand selected these 12 examples to go over multiple different factoring techniques to help you better understand how to simplify your rational expressions. I know by the time at the end of this video, you will have a better understanding of factoring and simplifying rational expressions. I hope you enjoy.
Welcome, ladies and gentlemen. So what I'd like to do is show you how to simplify rational expressions by factoring out the GCF. So what I have here is 4 different examples, and I'm going to show you how to factor out the GCF and then simplify the rational expression. Now, again, when simplifying rational expressions, when we have to use factoring, the main important thing is knowing how to apply the difference quotient. Besides knowing how to factor, we need to understand the difference quotient, which basically means when we have terms that are exactly the same in the numerator and denominator, they divide to 1. Or if we have expressions that are exactly the same in the numerator and denominator, they divide to 1 as long as they are separated by multiplication. And I'll kind of explain that here as we get through the problems. So in the first example here, I have 5x plus 10 divided by 15x plus 5. Now, when we're looking into doing that, solving by factoring, the first thing we're going to do is look at the numerator and the denominator separately and determine what can we actually factor out. So in the numerator, you can see that the 5x and the 10 both share a 5. So what I can do is factor out a 5, and what I'll obtain is 5 times x plus 2. In my denominator here, I can see that, again, they also both share a 5. So therefore, when I factor out a 5, I'm left with 15. When I factor out, basically it's like dividing out. So 15x factored out of 5 is going to leave me with a 3x plus 1. Now, by simplifying using the division quotient, I see that I have 5 over 5, which is going to divide to 1. And therefore, I'm just left with the final answer of x plus 2 over 3x plus 1. Yes, I'm not going to use where we know x. Yeah, I guess I should use the constraints. So remember, in our denominator, we also want to make sure what our denominator cannot equal. So we say 3x plus 1 cannot equal 0, and then we solve. And therefore, x cannot equal negative 1/3, right? Because remember, our denominator cannot equal 0, so we go ahead and solve. And just put that as a constraint. We don't really need these parentheses here. X cannot equal negative 1/3. So now we go over to here, and again, we're looking into what our common factors are. In our numerator, in this case, we can see that they not only share a 3, but they also share an x. So when I factor out a 3x, I am going to be left with an x minus 8. When I go ahead and factor out here, I can see that they also share a 3x, so I'm going to factor out a 3x. And here, I'm going to be left with an x plus 4. Again, similar to like this example, my 3x divided by 3x divides out, so I'm left with an x minus 8 divided by x plus 4. Now, it's very important. I didn't go over it in this one, but remember I talked about the division property only works when terms are exactly the same. But that's only when they're separated by multiplication. You can see this is 3x times x minus 8 and 3x times x plus 4. Here, we can't divide out the x's because they're not multiplied by anything, right? They're not separated by multiplication. You can see they're separated by subtraction with 8 and addition with 4. So therefore, I can't divide this out. But by using my constraint, I say x cannot equal 4. X plus 4 cannot equal 0. Subtract 4, x cannot equal negative 4. All right, so now we go into this example where we look at the numerator. I only have one expression. I can't factor anything out with that, so I'm going to leave that as a 4x squared. However, in my denominator, I can see that they both share a 2 and an x. So when I factor out a 2x, I am left with now a 3x minus 4. And now we can see that I can divide out the 4 and the 2. And by using the rules of exponents, I can divide x squared over x, which is just going to leave me with a 2x in my numerator. So that divides to 2. And those divide to x to the first power. So I'm left with the 2x to the first. And then in my denominator, I have 3x minus 4. By again using my constraints, I'm going to do this a little bit faster. We know that 3x minus 4 cannot equal 0. So by solving for x, I say x cannot equal a positive 4/3. All right, in the last example here, You can see this is looks pretty confusing, right? But basically, again, just focus on the numerator and the denominator. What does the numerator, what terms does the numerator, what terms do our two terms in the numerator have in common, as well as what terms do our denominator have in common? So up here, you can see that I can factor out the highest power I can factor out. That's really an x to the first power. So the highest factor of x I can factor out, or the highest power of x I can factor out is an x. And then I can factor out a y cubed. When doing that, I am left with an x plus 4. Then I go ahead and look at my denominator. And again, I can only pull out an x. And I can pull out a y squared. And when doing that, I'm left with a y minus 3. OK, now again, we're going to use my division property. And again, you can see these are separated by multiplication here. So I can divide these out by using my division property. And then by using my rules of exponents, I'll subtract the powers. And I'm left with a y to the first power. So I have y times x plus 4 divided by y minus 3. And again, notice that this y is separated by this by multiplication, but this one is not. So therefore, I cannot divide out the y's. Therefore, we also know that y cannot equal a positive 3. So there you go, ladies and gentlemen. That is how you simplify rational expressions by using factor, not a GCF. Thanks. So if you guys remember my operation for you, basically we need to identify, when doing these, we want to make sure that we can simplify, Christiana, the factors. So basically, we want to factor the numerator and factor the denominator. That is going to be true for all of these problems. So if you guys take a look at this, I have x squared plus 3x minus 18. We need to go ahead and factor. So again, this is a trinomial where a is equal to 1. So I basically need to find what two numbers multiply to give you negative 18 and add to give you 3, positive 3. Well, I can determine that that factored form is going to be this. Because I can verify 6 times negative 3 is negative 18. 6 plus negative 3 is positive 3. Then over, I have x squared minus 36. That's a difference of two squares. Would be x minus 6, x plus 6. Then we can apply the division property whenever we have a number or a term or an expression that's exactly the same in the numerator and the denominator. It divides to 1. Remember, they have to be exactly the same. You can't divide x plus 6 and x minus 6. They have to be exactly the same. So therefore, your final simplified answer is x minus 3 divided by x minus 6. Right? In this example, ladies and gentlemen, we have x minus 4 divided by x squared minus 8x plus 16. Now, in this example, you guys can see, again, what I talked about. We have exponents, right? But in this case, we have exponents, though it's still, again, we're being separated by addition or subtraction. So when we are simplifying our rational expression, the first thing we need to do is factor. See if we can factor. Yes? We always want to see, can we factor anything in the numerator and denominator? So we look at the numerator. Is there anything we could factor in our numerator? No. What force? But again, remember, as I told you, this you cannot factor that. You just can't simplify across. Okay? You have to look at them as group terms. I know it's very confusing. A lot of people want to do the same thing. But you cannot simplify across addition and subtraction. So can we simplify this denominator? Well, to do that, let's go and take a look. Remember, a times c and b. Now, fortunately for you guys, a times c, or a is 1. So our a, 1 times 16, is going to be 16. And then we have negative 8. So remember, this AC method tells us what two numbers multiply to give us positive 16, add to give us negative 8. Negative 4 and negative 4. Which hopefully, if you guys would have, on your homework, you would have noticed that these was a perfect square trinomial. Yep. OK. OK.
Don't forget the mustard. Wait, are both those supposed to be multiplication signs of the x?
Whoa.
One is supposed to be one, right?
You just do all that?
So now, as you go ahead and write this, you get x minus 4 times x minus 4. OK? Does everybody follow me with this? Paco, you follow you, OK? Yep.
You only write it once.
We need to learn math.
Yeah, I am not done yet. I was waiting for people to catch up. So the main important thing I want everybody to understand is once we come from this, Casey, is we go from here, we factor it to get to this point, x minus 4 times x minus 4. So now we factored it. We understand that x minus 4 divided by x minus 4 divides to 1. So we still have a 1 up top there. Do not get that confused. A lot of people say, oh, I cancel out and it's no longer there. No, there's still a 1 up top. So there's a 1 up top, and there's an x minus 4 in the denominator. There's only 1 left, is x minus 4. That's the only thing left. This got factored to this. I factored this out to that. Now that I've factored that out, those two divide to 1. So I'm left with the 1 divided by x minus 4. Does that make sense?
Where you got that 1 from?
Because again, remember, x minus 4 divided by x minus 4 is what? What did this divide to? What's 3 divided by 3? 1. X minus 4 divided by x minus 4 is 1. OK?
All right. So let's go and talk about simplifying, all right? So ladies and gentlemen, let's, if we're going to go back through, I just want to do a quick little review on multiplying and then simplifying. So I have some problems up here which you guys can write down, but let's do a quick little review here of how to multiply fractions, all right? So if I said I wanted to multiply 3 times 4 times 4 times 5, right? When we multiply fractions, does anybody remember what you do with the numerators and denominators? You multiply straight across. We don't cross multiply? No, right? Cross multiplication is only used when you have a proportion, meaning a ratio equal to another ratio. So we're not going to apply cross multiplication, which is the most common mistakes people forget because they say, oh, cross multiply, cross multiply. When you multiply fractions, you multiply across. Right? Does that make sense?
Yes, sir.
Okay. Now, ladies and gentlemen, what if I just did something like this? X plus 1 times x x over 1 times 5 times x over x plus 1.
Cross multiply.
You're not going to want to cross multiply, but you just do the same thing, right? You multiply across, correct? It doesn't matter if it's a polynomial or if it is a number or a binomial or anything, Caden. You're just going to multiply across. So in this case, I would have x times x plus 1 divided by 5 times x plus 1. All right? Now, the next thing I want to get with you guys. When we have a fraction that's written as 12 over 20, we didn't say, hey, leave your answer as 12 over 20. We always asked you to do what? Simplify, right? So we'd have to say, you know, what can I divide in the numerator and my denominator that's exactly the same? You say, what's the largest? You can say, well, 4. So I can divide everything by 3 over 4 on the top and bottom, and I'd get 3/5, right? Divide the top and bottom by 4 because that's redundant. Now, let's look at the second equation, or second problem. Is there something, without multiplying this out through, right? I could multiply this out, but is there something that they already share that can cancel out? X plus 1, right? So in reality, this answer is just x over 5. Correct? Right? Because those cancel out. They divide into 1, as we should actually say. Right? X plus 1 divided by x plus 1, that's the same. It's redundant. Just like the 4s are redundant here, right? But what I want you guys to do is, now what we're doing is, so that's a quick little review on the multiplication. All right? So how are we going to do this? Well, how are we going to reduce problems when we multiply with fractions or multiply polynomials? So one thing I want you guys to understand is, this is what it's like in simple form, right? And we simplify them. So when I have a problem, or if I have a number and I want to see how can I rewrite to simplify it, I could say, well, I can both divide a 4 by this, right? Meaning I can rewrite this as 4 times 2 and 4 times 3, right? So by factoring out a 4, what I'm really doing is showing this as a multiplication problem is 4 times 2 times 4 times 3. So now I cancel out my 4's, so my answer is a fraction of 2 times 3. Same way I did it here, I just divided by I just factored out the 4 on the top and bottom. Now, this was pretty easy to see that you can cancel out the x plus 1, right? But what if you were to multiply this through? What if you had x squared plus x divided by 5x plus x? Would it be so obvious that you'd have to cancel something out? This, you guys are pretty used to this, right? Hey, I know they're both divisible by 4, so I can rewrite it and I can knock out the 4's. Here, this is not very obvious that x plus 1 is a common factor, is it? Is it very obvious? No. So ladies and gentlemen, when we're going to be multiplying, dividing polynomials, it's going to become very, 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 very Sam, very, very, very Seaver, very, very important that we factor. So here's what we're going to want to do. So for this problem, I have x squared minus 4x plus 3 divided by x squared minus 6x plus 5. So the first step you guys are going to want to do is factor. Okay? So for these problems, when we're going to be multiplying and dividing, we're going to want to factor. In this case, we're dividing a polynomial by another polynomial. So what we're going to want to do is factor. Do you have that written? Yeah, okay. So let's factor the top.
Yeah.
What am I?
X squared minus 3, x minus 1.
Huh?
X minus 3, x minus 1.
Then on the bottom,
Minus 1 and minus 5.
now as a factored form, do you guys now see? Are these equal? Or are they the same? Same thing. Just one is in factor form, one is not, right?
Yes.
But now, once we have this factored out, do you guys see how now I can simplify this? X minus 1 divided by x minus 1, ladies and gentlemen, is just 1, right? So therefore, you're going to leave me with x minus 3 over x minus 5. And there you go. That's going to be your simplified answer. Okay?
Take the x out.
So what I have up here, ladies and gentlemen, is I have 4y squared minus 3wy times without y plus 2 divided by 3y minus 4w times 5y plus y. 5w plus y. Oh, it's a lot, right? So the main important thing, guys, what I like to do when I have multiple terms is I want to write them out separately and see what can I factor and what can I not factor. All right? So let's rewrite this. 4w minus 3wy. Can I factor anything out of those terms? W, right? Factor out a w, I'm left with 4w minus 3y, right? Very good. How about y plus w, or w plus y? Can I factor anything out there? No, so that's just going to remain the same. 3y minus 4, can you factor anything out there? 3y minus 4w, can you factor anything out? No. How about 5w plus y? Can you factor anything out?
No.
No. So the only thing I have is 4w minus 3y. So let's rewrite this. So I have w times 4w minus 3y times w plus y divided by 3y minus 4w times 5w plus y. So ladies and gentlemen, do we have anything that we can divide out right now? Yes?
I was just wondering though, is it possible to like put the like terms together in like one side and then do that?
What do you mean, like
Like with
terms?
the W's in one half of the thing and then the Y's in the other half?
Well, each term has a w and a y.
Yeah, but I'm saying like you split those up and then, because it's all.
But it's all multiplied, so there's not really something we can change. I mean, I'd have to distribute these. But this is this times this times this, so they're all multiplied together. I can't really rewrite it any further than this, except for just switching these around, or switching those two around. But I can't keep the w's together or the y's together. because then that would undo the operations that are happening. But yeah, if there was going to be two terms that would divide out, does anybody know which two terms would look like they could divide out? Yes?
W plus y and 5w equals y.
No, 4w minus 3y.
And what?
And negative 3y negative 4w.
Okay. Well, that's very close. Yeah, we can't, unfortunately, we can't divide this because this isn't the 5 times this. So yes, we can't, these aren't going to divide into them. They're not even the same, but even if they were the same, you can't divide them out through multiplication. We can't even divide 4w minus 3y divided by 3y minus 4w because they're not exactly the same either. Right? Let's pull them out. 4w minus 3y is not the same thing as negative 4w plus 3y. Do you guys agree with that? I just rewrote it. I rewrote it so the w's are by each other and the y's are by each other. That's not the same thing. They do not cancel out.
They don't.
However, what I can do is I can factor out a negative 1. If I factor out a negative 1, then that turns to positive and that turns to negative. So now, ladies and gentlemen, when you factor out a negative 1, are they now the same? Yes. So what I can do is, if I make this negative, then,
You can't just change the dollar.
yeah, you can. I'm not changing it. All I'm doing is I'm factoring out a negative 1. So I'm not changing the problem at all. I'm just factoring out a negative 1. You want me to prove it to you?
Do
Okay.
I have to do this?
So therefore, w times w plus y divided by, it's now negative 5w plus y. So now this is the problem. These two terms are able to divide out, but now the problem is turned from a positive to a negative. Okay?
All right. So in this example, ladies and gentlemen, I have 5x times x squared plus 4x plus 3. Okay? And what I'm going to do is I'm going to have x minus 6 times x squared minus 9. All right? So what we're going to want to do in looking at this one is look at the exact same case that we're going to want to do. When we're dividing, our main important thing is we're just going to want to make sure that we can simplify these as much as possible. So let's go and factor out. So there's a couple that we can factor out. We have x squared plus 4x plus 3 we can factor, right? And that can factor into x plus 1 times x plus 3. And then we have another one, x squared minus 9 we can factor, which is x minus 3 times x plus 3. Does everybody agree? Can I factor 5x into a different factored form? It's already factored. Can I factor x minus 6 any further? No. So now I'm just going to rewrite it in its factored form. So I have 5x times x plus 1 times x plus 3 divided by x minus 6 times x minus 3 times x plus 3. Now we look at this and say, all right, now what is going to simplify?
Take out the x plus 2.
Right? And you can say what?
Take out the x plus 2.
X plus 3. Very good. And then looking at it, then we just have our simplified version, which is going to equal 5x times x plus 1 over x minus 6 times x minus 3. I mean, this is factor form, it would be fine. Okay? Okay, so here we go. Now we got some problems that are going to be really, really fun to look at this, because I know you see this and say, oh, a is not equal to 1. I hate these types of factoring problems. So that's okay. That's why we're going to do it. I'm going to show you step by step how to go through each one of these, and I'll show you 2 different ways to do it. Obviously, the fastest way to do would be the factoring in your head, but I want to make sure I go through this step by step so you can at least understand what exactly we're doing. So before we even get to that point, we always want to look at, can I factor out a GCF in my numerator or in my denominator? And unfortunately, in both these cases, they do not share a GCF. Then the next thing I want to do is always look for special factoring techniques. And unfortunately, I do not have any special factoring techniques I can use. There's no perfect square trinomials or difference of 2 squares or 2 cubes. So I'm going to have to go back to the nice nitty-gritty and factor. So you notice that I have my 2 polynomials in the form of ax squared plus bx plus c. So to do this, I'm going to factor here. Let's do the numerator. And let's go ahead and factor the denominator. Now I'm going to do this 2 different ways. However, the first part is always going to be the same. When factoring a trinomial, when your a is not equal to 1, we need to make sure that we determine what our not just c is, but a times c is, and then what our b is. So we need to figure out the value of a times c and then b. So for my numerator, a times c is going to be equal a negative 24. And my b is going to be a positive 10. My a times c over here is, for my denominator, is going to be 6 times 6, which is 36, and then a positive 13. All right, so I'm not going to write out all the factors because I am going to try to speed this up a little bit for you. So when we look at this, we just need to figure out, all right, well, all the factors are negative 24. So since it's a factor negative 24, we know that one of the factors has to be negative. So what 2 factors multiply to, well, we already know the value, the factors that multiply giving negative 284, but out of those factors, which ones add up to a positive 10? Well, our factors in this case are going to be positive 12 and negative 2 because they multiply to give me negative 24 and add to give me 10. Over here, you say what 2 values multiply to give me 36 but add to give me 10. Now, both the factors have to be positive because rather than just multiplying to make us positive, they have to add to give us positive as well. So they both can't be negative. And those 2 factors are going to be 9 and 4. All right, so the first way we're going to do this is we're just going to simply rewrite it by using our new terms. So I can rewrite this as 8x squared. And then rather than using 10x, I'm going to use my 2 factors to represent that. So I could say plus 12x minus 2x minus 3. OK, so all I simply did is instead of writing 10x, I wrote 12x minus 2x. It's the exact same thing. But the reason why I do that is because now we can use the technique of factoring by grouping. And factoring by grouping we like because what we're going to do is we're going to split it up into 2 different groups. And then we're going to factor by the GCF. And a lot of us are used to factoring by GCF because that's what we first learned when learning how to factor. So I look at my first 2 terms and I say, all right, what do those 2 terms have in common? We could say they both share an x and then also a 4. So if I take a 4x and I factor it out, I'm going to be left with a 2x plus 3. Then over here, I can say, all right, well, whatever I want to factor out to this, I want it to be the same as that. And I'll explain that in a second why. So you say, what can you factor out? Well, you can factor out a negative 1. So when I factor out a negative 1, I'm left with a 2x plus 3. All right. So what we did is we said, all right, what is the GCF of this first binomial? And then we factored out the GCF of the second binomial. So when doing factoring by grouping, you do a GCF first, GCF second, and then you say, all right, what is the GCF then of everything? And you notice that this whole expression, this binomial, the GCF is going to be 2x plus 3. So now you factor out the 2x plus 3. And when you factor out the 2x plus 3, you're left with a 4x minus 1. So therefore, that's going to be now my new numerator, which is in factored form. 2x plus 3 times 4x minus 1. OK, so now we need to determine what the denominator is. And to do the denominator, I'm going to use the box method. And what the box method does is it goes by the understanding of multiplication creates area, right? If you look at this, if I say this times this gives me that, which is true, right? That's what we did by factoring by grouping. Well, you can understand if this is the length, this is the width, then this would represent the area. So let's just create a nice little box. So what we're trying to do is if I'm given an area, we're trying to work backwards and say, all right, what were the length and the width? What were the 2 values that we had to multiply to give us that area? So far in our area, we know that we have a 6x squared and a positive 6. But we have 2 boxes. Which one are we going to put the 13x into? Well, that's where this comes into play. Just like how I rewrote our middle term here, I can rewrite my 13x as 9x, and 4x. All right, and that helps us fill in our boxes. Now we just need to determine what are the lengths of the box that create that area. So I'll just show you a little guess and check on why some things work and why some things don't. So let's look in the upper left-hand box. We know that 6x times x gives us 6x squared. However, 6x times what gives us 4x? Well, that's going to start getting into a fraction, right? We don't want to deal with fractions. All right? And what happens if you do it the other way? Well, x times 6x squared, yeah, that gives us there. And x times 4x would be a positive 4. However, 6x times what gives us 9x? Again, it's another fraction. So that's not going to work. Now, I know that the other two factors of 6x could be 3x, and 2x. However, notice that 3x is going to have to multiply by a fraction to give us 4x. So let's rewrite them the other way. All right, 3x times 2x gives us 6x squared. 2x times what gives us 4x? Well, that's going to be plus 2. And then over here, 3x times what gives us 9x? So that's going to be plus 3. So therefore, now those are my two factors. So I can rewrite them as 3x plus 2 times 2x plus 3. And there you can see that I have a binomial divided by the same binomial, which will result into 1, leaving me with a simplified rational expression of 4x minus 1 divided by 3x plus 2. So there you go, ladies and gentlemen. That is how you simplify a rational expression by using your AC method to factor and then simplify. Thanks. All right. I guess I'll stop joking. All right. I don't have a problem going ahead and solving a problem like this for you. But the main important thing I want you to look at is, when you guys look at it simplifying our trigonometric expressions, obviously we cannot apply our properties of exponents because, these are all separated by addition and subtraction. So we want to look into factoring. And, when looking at factoring, when we have these good old trinomials, I can say, all right, what two numbers multiply to give me 15 that are going to add to give me negative 8. You just keep on working through and you're like, all right, I got it in my head. I'll figure this one out. But then we get to one of these larger ones and you say, well, what do I do with a term like that? Well, when we have 4 terms, that's going to be especially in factoring technique that we're going to want to apply.
Please report to my office.
So to do a problem like this, what we want to do is apply the grouping technique. And if you remember the grouping technique, the way that it works is if we have our 4 terms, we're going to break up the first 2 terms and then the last 2 terms. Then what we're going to want to do is factor out each one of these terms by their greatest common factor. So if I look at x cubed minus 5x squared, I can see I can factor out an x squared. By doing that, I'm left with an x minus 5. Up top, for negative 3x plus 15, what I want to do is factor out, again, another common term, so I can factor out a negative 3. And I'm left with an x minus 5. And the important thing when factoring by grouping is that you want to make sure you factor out the same enough factors, so therefore you have your common factors out here that you can factor out again. So here you can see that in out of each of these 2 terms, right, because now they're separated by subtraction, you can see the only thing they have in common is an x minus 5. So when I factor out an x minus 5, I'm just left with an x squared minus 3. So now I'm going to rewrite my expression to have x minus 5 times an x squared minus 3. OK, and then what we do is we go ahead and factor this. Well, x squared minus 8x plus 15. You guys might be thinking at this and say, all right, well, what 2 numbers multiply to give me 15? What type of numbers multiply to give me 15, but add to give me negative 8? Well, that can be hopefully negative 5 times x minus 3. So therefore, I can say this is x minus 5 times x minus 3. Well, therefore, my x minus 5 divides into my x minus 5. However, we look at this, and a lot of you might say, oh, well, why can't the 3's cancel out or the x's and just be left with x at the end? This is x squared minus 3, and that's x minus 3. These are not same terms. They're separated by subtraction, so you can't divide one into the other, but not into both. And unfortunately, ladies and gentlemen, that is just going to be our simplified answer for this expression. We cannot simplify this any further. So that will be our final expression. So there you go, ladies and gentlemen. That is how you simplify a rational expression. Thanks. All right, come on. You got to smile when you see a problem like this. You look at it and you say, all right, I've been going through rational expression, rational expression, rational expression. I think I kind of got it. And then you now throw in some cubes. What is going on? What am I going to be able to do on this one? I have absolutely no idea. But that's OK. I'm just going to work you through this problem to go through it. But I think this is one that gives me a smile because it's like, man, there's so many different components going on with this. So let's always just start with the basics of what we're looking at. Again, remember, we want to simplify our numerator and then simplify our denominator as much as possible. So before even getting crazy, I noticed that I can simplify my numerator because they have a GCF, and that's good. That's always the first thing. We don't want to look at make things so much complicated. Just because we see a cubed, don't say, I don't know how to factor with the cubes. Let's just break this down very simply and say, all right, they have a GCF. I can factor out actually an x. That's going to make that x squared, so it's a-OK. Now, I can factor not just an x, but also a 3. So when I factor out a 3x, I'm now going to be left with an x squared plus 2x plus 4. All right, now inside this is something that I can simplify by factoring. And even more importantly, we could see that, OK, actually, I cannot break that up. I had it switched around. That is not something we can factor further down because there are no two numbers that multiply to give me 4 that add to give me 2. So unfortunately, we're kind of stuck at that point. But that doesn't mean we need to stop because remember, we still need to simplify our denominator and see if we can eliminate anything. Now, you look at your denominator and you say, well, that doesn't look any easier. That doesn't look like it's going to eliminate anything in my numerator. But we do notice it's a cubed. And when we're looking at a cubed, we want to look at, can we factor out a GCF? Or can we use the difference of 2 cubes? So remember the difference of 2 cubes. If I have a cubed minus b cubed, we can rewrite that as a minus b times a squared plus ab plus b squared. All right, so in my case, I have x cubed minus 8. All right, so I need to make sure, is 8 a cubed number? Yes, it's 2 times 2 times 2. So therefore, I can rewrite that. So if a cubed is a, then therefore I could say that I have x cubed, or the cube root of x. Cube root of x cubed is x, and the cube root of 8 is going to be 2. So I can have this as x minus 2 times x squared plus 2 times x plus 2 squared. All right, now I can simplify that into x minus 2 times x squared plus 2x plus 4. So let's now write that in our denominator. So we'll have x minus 2 times x squared plus 2x plus 4. Well, what do you know? Lo and behold, this huge complicated problem has actually done us a great favor because since this is distributed across multiplication, I know I can just separate these and say, all right, well, this is being divided by that, which is going to leave us with 1. So we don't need to keep those up there. We can just multiply our final version of our simplified rational expression, which will be 3x divided by x minus 2. So there you go, ladies and gentlemen. That is how you simplify using difference of 2 cubes and factoring out a GCF. Thanks. So f was negative x cubed plus 2x squared minus x all over 1 minus x to the 4th. So the first thing I would do, guys, is I can factor out an x as well as factor out a negative. So if I factor out a negative x, that's going to leave me with an x squared minus 2x plus 1. And again, if you're not sure if I just did that correctly, multiply it back. Make sure if you multiply negative x times all of those, it makes sense. It works. Right? And you can hopefully do that in your head. And you can say, OK, yeah, he did that right. I'm going to rearrange this. And remember, when you rearrange this, you can see that, well, if I factored out a negative, I would get a x to the 4th minus 1. Right? Actually, I'll just do it here. Negative x to the 4th. Oh, when I said, I was going ahead of myself. When you are go ahead and rearranging this, then make sure that, because this is equal to that, when you go ahead and rearranging it, that make sure you keep the signs with them. So this is factorable. That's a perfect square trinomial. X minus 1 times x minus 1. You could write it as squared, but I think when you're simplifying radicals, it's a little bit, or simplifying rational expressions, it's easier to have them just as factored form. Here, if I factor out a negative, that's x to the fourth minus 1, right? Which can turn into now, let's see here. Actually, let's go and do that. Do I have room over here? Yeah, so let's actually factor that out. X to the fourth minus 1 is a difference of two squares. X squared minus 1 times x squared plus 1. And then that can be further factored down into x, let's see, x squared, x minus 1 times x plus 1. All right, so now we have a final negative x times x minus 1 times x minus 1 all over x minus 1 times x plus 1 times x squared plus 1. And therefore, you guys can see my final answer here is a negative x times x minus 1 all over x plus 1 times x squared plus 1, where x cannot equal negative 1 and 1. Right? Yes? Probably, because I forgot about it, right? Yes. So you could have a negative or make them both. Or you could recognize that you have a negative over negative. So therefore, we could also just make it positive, right? And that's important. If you guys saw that like in your final answer on a multiple choice test, it's probably going to be positive, right? So you need to recognize that the negative and that negative there divided out, or divided to make a positive. OK? So for instance, oops, that's squared. Can we factor like this middle problem rather quickly? Yeah, like we learned how to raise the powers here. And then here I say, oh, there's 4 terms, so I should probably do factor by grouping to make 2 binomials. So I have x squared plus 3 times x squared plus 2. And then here I can factor this out. Wait, what happened here? Did I factor that correctly? No, I didn't. Did I? Factor out a 2x. Oh, that doesn't work. Just got to factor out a, that's a 2x minus 3, right? So I can only factor out a what? X? Squared. Yeah, there you go. There. Oh, OK. So I have an x squared plus 3 times 2x minus 3. So now what you can see here is the x squared plus 3's divide out. And I'm left with a x squared plus 2 all over a 2x minus 3. Now, my x, I have only one restricted value, which is a 3/2. Right? Because if you set 2x minus 3 equal to 0, you'd get positive 3/2. But why don't I use this one? Why doesn't this have a restricted value? Not because it got divided out, but what happens when you solve x squared plus 3 equal to 0?
You get I.
You get I. You're dealing with complex numbers. We're not going to call I a restriction on this domain. It's only for real numbers. Yes?
So when you factor out, can you not factor out as soon as the 9 doesn't have x value next to it?
Where are you factoring a 9? I factored out a 3. You can only factor out a number that both divides into 6x and negative 9, which is only a 3. Anybody have any questions here?